But it's so much my pleasure to introduce Dr. Seth Campbell, the lead of the Juneau Icefield Research Program. And I just want to give a little bit of a background. I am the interim director for the UAF Upward Bound program. And I spent my summer from high school to college on the Juneau Icefield Research Program, like 25 years ago. It's getting to that time. So it was so influential in my life. I'm not sure what the pathway was where somebody recommended to my parents that I fill out the application and I go. But I can tell you that this kind of expeditionary learning program has influenced the rest of what I've been doing in my professional education career, as a teacher for 18 years, as a program coordinator, as a director. I've always tried to bring expeditionary learning opportunities in. And what I want you to kind of be listening for and taken away is Seth is going to share with us this amazing, awesome research program, Juneau Icefield Research Program. But there are programs like this in each of your communities, in each of your states, and part of what we have an opportunity to do as TRIO programs is find ways to bridge and to reach out to them, because I guarantee you, we have a population that we work with that's really excited about, having these kind of opportunities. And the grant writing folks, or the people who do research in our institutions, do also have the similar goal of expanding what they're doing. Seth is part of T3 Alliance, or well, he's coming in as one of our T3 Alliance sponsored programs. And for those of you who don't know about T3 Alliance, just a quick, and could I ask if you're in and you mute yourself, that'd be great, just so we don't hear background stuff. There we go. But yeah, what I was saying, T3 Alliance is a group of programs around the country that have been focused on working with helping students find ways to use technology in community engagement opportunities. And Seth reached out to us a little while ago saying, hey, we've got some students, we have an amazing research opportunity, and is there a way that some of the technology that you guys are using as part of T3 Alliance can connect in? So with that, I'll leave it in Seth's capable hands to take you on an adventure, learn about the Juneau Icefield Research Program and expeditionary learning. And wow, we're getting a lot of people who are joining in last minute. So it's wonderful to have you here. And if you have questions, throw them up in the chat or unmute yourself and reach out. We're a real informal group here. We just are excited to share what we've got going, and thank you for being here. So Seth, it's yours.
Awesome. Thanks, Adam. I'm going to share my screen here. All right. Can everyone see that? Thumbs up. Awesome. Super. All right. Thanks very much for the introduction, Adam. And I'll note Adam invited me to this conference, and this has been probably one of the most fun meetings I've been to in the last 10 years, just to kind of not be science overloaded and chat with educators that are really stoked about working with students. So Adam did a good introduction about the program. You're going to see through this program, I'm stoked about working with students and trying to engage them in ways that they don't traditionally get a chance to be engaged in. And I figured I'd start with asking everyone here a question. So the first question is I kind of want everyone to think back to your first experience. What really inspired you in the things that you do that you love, and also what inspired you as an educator? And I kind of wanted to open up the floor and either have people chime in. We have a small enough group here, so I think people chiming in vocally would be great. And while you're thinking about this, I share this photo. This is me with my 8th grade class from small town Maine. For reference, 3 out of the 12 went to college. All 3 went to college for sciences as a result of the teacher we had. There was a big inspiration. Of the 12, I think 2 others have passed away from drug alcohol related issues, and 3 have done jail time. So it's kind of a classic small town, not a lot of opportunities where I grew up, but I had that one mentor that stuck with me. And I bring that up keep that question in mind. I bring that up because 23 years later, I brought that mentor to Denali National Park and worked with a program called Polar Trek to bring our research back to their classrooms in Maine. And I'm consistently doing that on a year by year basis. And so, this picture is me here with the teacher here that was my educator 28 years ago. So back to that question, what was your inspiration? And the reason I'm asking this is I want you all to kind of put yourself in your student's mind again. What's that thing that they're going to remember from going up, whether it's the mentor, a specific experience. Most of us know you're not going to remember that equation that was written on the board on a specific date. It's something else that happened. So with that, I'd like to open the floor for a couple minutes before we move on.
Hi there, Seth. This is Kyle Campbell at the University of Alaska Fairbanks, and I'm really excited to hear more about your program. I've kind of viewed it from a distance. So I'm the STEM coordinator and advisor for the Student Support Services program here, and really excited to get to work with Adam and the whole T3 Alliance crew. This is such a great sort of prompt and one that's been very much on my mind. So I'm currently sitting on the chair of a nonprofit science education, nature education board here in Fairbanks, mostly because it's exactly this question. I'm alumni from the very first cohort of called Camp Habitat, started in 1990. And so, yeah, I've just been thinking about how to articulate some of these things of that was not only my first introduction as like a young learner into some of those things, but in high school, I worked as a junior counselor for them and I've just stayed involved with that. And so I really love this kind of seeing this full circle that you're sharing with us here. So it's, yeah, so for me, it would be the summer education camp here in Fairbanks that I'm still involved with now. I've worked as a special guest instructor for years. So,
awesome. Yeah. That's great. That's super example, Kyle. Thanks for reaching out. Anyone else?
I am Jasmine Johnson. I'm in Miami, Florida as the director of an Upward Bound program. And I was an Upward Bound participant when I was in high school. And just, the collection of experiences of traveling and being on a college campus and things like that, those are things that really impacted me. So I definitely knew that college was my next step. And then in college, I was a youth development major and we had quite a bit of adventure education courses. And those courses definitely shifted how I view education and the importance of experiential education and challenging yourself and kind of not looking at each other, but looking at how can you better yourself every time. And those kind of experiential things added so much value to everything that we were learning, that I know that I tend to add those kinds of experiences and real life contextual experiences in general to my program.
Awesome. Thank you so much. That's those are all super examples. Anyone else?
I'll jump in there. I think I got hooked when I was I'm part South African. I was living over there and working for a program called Educo, which took urban youth out into nature for a week on leadership courses. And it just blew my mind how these young people, who many of which had never been outside of the shanty towns that they live in, were in the beginning frightened of the wildness of the place we brought them. And within a 20-minute solo, 80% of them would be quiet and in awe and having recognized a part of themselves that they'd never known, but it was a recognition more than something new. And so that's why I've been committed to, I guess, youth development from then on. I'm not an educator, but experiential education really blew my mind in that context.
Awesome. That's great, Alex. Cool. Anyone else? I know we have a couple more here.
Yeah, I'm Sandy James. I'm a talent search advisor at Southwestern Oregon Community College. And before I did this, a few jobs before I did this, I was a mental health counselor and a wilderness counselor. So I worked with adolescents, young men who are having trouble doing life. And we did a lot of overnights or week-long wilderness therapy type things. And especially for this age group, that I work with. I do pre-college, talent searches pre-college. An adult just talking at them is usually not real effective, but doing experiential learning is just way more effective at getting through to the age group I work with.
Awesome. Thank you so much, Sandy. Cool. Anyone else? All right. Well, we'll keep moving on from here. Those are all perfect examples. Just keep those things in mind, because that's the premise of what I want this conversation to be about. Now, I'm going to jump back into the science. Like, what do we do from a science perspective? Well, one of the take-home points that I think everyone here probably knows, less than 25% of students in the US have some geoscience training in high school, or earth system science training. That's a really small amount. And from my perspective, that potentially is one of the major issues we're facing in terms of environmental challenges down the road. The fact that the vast majority of environmental challenges we're facing also disproportionately impact low-income students, minority students, and families, as well as just populations that don't necessarily have the resources to deal with the environmental challenges that we're facing. So I took JIRP over a few years ago, and my goal was to start trying to use the program to the benefit of these populations. And I'll talk a little bit about that. But the first thing I want to explain is what we try to do on the program. And one of the things we try to do on the program is give a full contextual understanding of Earth system science from a visual perspective, putting students on the ground in the environment to learn about these locations. So I'm going to flip through some basic science concepts for the next few slides. I'm not going to harp on them, but this is just a simple example of, we know glaciers cover much of northern North America. All right, this is a model that shows the actual retreat of the Laurentide and Cordilleran ice sheet across North America over the past 20,000 years or so. We also know things like temperatures warming over thousands of years. We know this from different science topics, looking at ice cores, sediment information. There's a whole number of processes that we can observe. So this model is from NASA, kind of showing warming temperatures. Red basically means it's getting warmer as you cycle through forward in time. And you'll see that the Arctic is amplifying. It's basically getting warmer and warmer relative to other areas. And Alaska sits right in that hot zone. As a result of that warming temperature, Alaska also happens to sit in the hot zone in terms of things like glacier retreat. So this is a figure that came out from some science research last year. The size of the circle denotes the amount of ice lost from glacier systems and mountain glacier systems across the world. And you'll notice Alaska is the biggest contributor to that mountain glacier system loss. All right, so another observation that we have in Alaska going on. Another one. This is a NASA visualization looking at sea ice trends. And I'm not going to let it go all the way through, but I'll speed it up. But you'll see anything that's white, this is sea ice. And the brighter white is multi-year sea ice. And this model starts in the 90s and it runs all the way through, I think, to last year, a couple years later. And as I speed this model up, you're going to see that white ice basically disappears. It almost disintegrates. So why is that important, right? Well, I'm getting at the fact that it's kind of Earth system science. It's basically all these systems kind of work together. If we bounce forward from a sea ice perspective, if we remove the sea ice, what happens in that response is you have much longer distances for waves to build up, which can basically cause more erosion. We know coastal erosion in Arctic environments are happening on an order of 20 meters or more per year, which has a big impact to local communities. It also has an impact of potentially reducing, causing an increase of carbon and methane emissions into the atmosphere. So there's a lot of multi-system science processes that are occurring, and trying to draw those links are important. And I'm going to go back to that geosciences comment, that 25% geosciences comment I made earlier. Right now, most schools have a lot of schools have maybe geoscience or earth systems alternative course they can take, but it's not necessarily required. A lot of schools in Maine, for example, they have chemistry, they have biology, they have physics, but it's rarely kind of coupled and partnered together. And that's what earth system science is about. This is just another model of showing carbon escape modeled going up to 2300 in future years as a result of climate change scenarios. And again, atmospheric warming, ocean changes, sea ice, glacier change, permafrost, they're all related. And that's the concept of Earth system science, is this interrelation. And now I'm going to hone into the Geno Ice Field. Geno Ice Field, this program has been around since 1946. It's the longest operating polar program, research and education program in North America, the second longest operating program in the world for this type of change. And the photo on the right is a beautiful location, my favorite place on the planet, probably the most inspiring place on the planet I've ever seen on the ice field. The image on the left is actually showing elevation loss of the Taku Glacier over between 2013 and 2018. That elevation loss and that size of the ice field, that's the Taku Glacier. Basically, Taku Glacier, we did the math just a few days ago. Basically, that would fill up Lambeau Field in Wisconsin once every day for that entire period of time. So that's how much from one glacier, and there's 60,000 glaciers in Alaska. You know, so kind of the visual of how much water is coming off of these systems is pretty huge. So what we're trying to do is we're trying to basically show that all these systems work together. And this is kind of a nice summary slide of all these systems kind of working together, the glacier system and the downstream environments, the Gulf of Alaska, which is one of the most important ecosystems on the planet. And the fact that you also have these huge teleconnection being from Alaska to the rest of the world, that are getting impacted by environmental changes that we're observing. So that leads to me to what we're basically trying to do on the ice field. And I think, you know, Adam brought me into this conference. It was almost a perfect fit because our mission on the ice field is we teach, train, and inspire the scientific leaders of tomorrow. You know, so it almost fit perfectly into your theme for this conference, the inspiring leaders from within. And JIRP is kind of unique in the academic world in a way because the program operates almost like a consortium of faculty and resources coming from dozens of institutions around the country, actually around the globe. And the concept is that environmental issues don't really know political boundaries. You know, global environmental change do not know political boundaries, but unfortunately, most academic institutions, most states, most countries are kind of divided. So what we're trying to do is we're trying to bring those groups together more so. We're trying to pool resources together where we can to get people working together, to exchange ideas. And on top of that, our education mission is to really foster long-term leaders from within their own communities. And my hope with a partnership that we're starting to develop with Upward Bound programs is to provide students from Upward Bound TRIO programs in the future opportunities to have dozens and dozens of science mentors from around the world that can help them start early in their career and progress to be a scientific leader in their specific communities. That's what we really need. That's what we're lacking in the United States and really globally, unfortunately. So my hope is that JIRP can help contribute to that. So the other thing that I'd like you all to take from this is if you have ideas on how to do that, if you have people you think would be psyched about this concept, please send them my way. You know, there's very few ideas that I've turned away. Usually I'm the type of person that responds to say, how can we make it happen? Because we need, there should be 50 programs like this. There should be 2 million trios around the planet, right? But we're limited with what we have for resources. So my concept of kind of working together on these types of initiatives is kind of my goal. So with that, we currently run one single program every summer. It's a small program. So Adam participated, it was probably about this size, maybe smaller back when you participated, Adam. Right now, we have about 35 students coming to the ice every year from around the world. Relative to geosciences, we have a pretty nice ratio, female, male, gender neutral, and as well as our faculty and staff, which is, I'm pretty stoked about this, especially when you look at the polar geosciences community ratio. When you go to Antarctica, where I spend a lot of my time, you know, you're talking 75, 80, 85% males. So I'd like to think that we're also making an impact of trying to provide early career opportunities in the polar geosciences moving forward. But you'll see the new programs that I have listed below, this TRIO Upward Bound concept that I'll talk about, and also taking what we have available from the ice field and bringing it back to the classrooms. My goal is to not just reach the students that we bring to Alaska. I want to make sure we're reaching students that don't have that chance to get to Alaska because of two things. One, not every student's going to want to go to Alaska. One, not every student's going to have the opportunity to go to Alaska, but that doesn't mean they aren't necessarily interested in the geosciences. And the geosciences, 90% of it is not going in the field. 90% of it is actually doing models and in the lab work and stuff that's in a building as opposed to being in the field. So I think there's a large component of students that we miss if we don't try to take this amazing resource and pass along the opportunities that we have here. And then the other thing we're developing a bunch of more early career training programs, and that's something I'll kind of leave out for the rest of this discussion, but we have programs chasing NSF and NASA funding to actually train the next generation of higher end scientists in the fields. So we've got some recent publicity. I'll show this very quickly, mostly because Ben Santer is one of our board members, but Ben was a lead author for the Intergovernmental Panel on Climate Change, 1995, Chapter 8, which was the first chapter that really indicated climate change being basically caused by human influence. So he was the lead author on that, and he's on our board of directors. And this is his statement, almost 30 years later from that original statement of studying climate change in one of the grandest classrooms in the world. It really is a spectacular area. And I'm speaking to you from having 60 field seasons around the world, including over a dozen to Antarctica, Greenland, Canada, Patagonia. This place is one of the most amazing places you will ever see. It really is an inspiring sight. The other thing I wanted to show is this story about women reimagining themselves in terms of who actually does science. I can't harp on this enough. We've been working really hard over the last few years to bolster opportunities for women, for underrepresented students. All of our scholarships go to underrepresented students. If you want to talk more about that, I'm happy to talk about that type of stuff offline. But that's really where probably 90% of our effort is going right now. So what is the program? What do we offer? So the program, generally we operate June through August right now, and we have 11 camps across the ice field. I'll show you a picture of what the camps look like. Of those 11 camps, we have tons of equipment at each camp. We have generally 35 students in the primary program now. The cool thing about JIRP is we have upwards of 50 faculty that volunteer their time every year from around the planet, which is pretty unbelievable. So this is 50 faculty from the polar geosciences community. But we get an additional 60 probably applications per year, and I can only take right now maybe 5 of those. And then we're maxed out where we have more faculty than we do students. So it's a pretty incredible ratio of faculty mentors to students on this 2-month program. I think that's a pretty rare ratio. We have teaching faculty that come in to specifically teach our academic curriculum. And we also have research faculty that come in on funded NASA, NSF, Department of Defense projects to basically do their research, but what they do is they actually integrate the students into the research. So imagine having 35 students with an opportunity to work on 6 or 7 different science projects on earth sciences, planetary sciences, glaciology, geology topics, polar engineering. These are all the things that students get a chance to do. So instead of one single internship, they get their hands on a bunch of experiences. We have medical staff that come every year, safety staff, professional safety staff that come every year that are professionally trained. We have upwards of people coming from upwards of 20 institutions per year to the ice field. And we get about 40,000 hours of volunteer time every year to support this program. So if you were to do the math, that's between $1 to $2 million of volunteer time from a salary perspective alone. And I equate this to kind of like a mini US Antarctic program. Most of you may be familiar with the US Antarctic program, where scientists go to Antarctica every year. There's about 1,000 people that go down to the ice to Antarctica every year from the US. We're about the size of the entire New Zealand Antarctic program. So that's that's probably sits right beside the US Antarctic program in terms of size. It's the next one down. I think there may be 2 or 3 that are bigger than the New Zealand program, but we're a pretty big operation in the grand scheme of things. That said, next year, so in total, we have about 84 participants to pull this off between the faculty and students. Next year, based on our plans for the upper bound inclusion, we have plans for upwards of 120 to 140 participants, with about 70 or 80, 90 when we include the upper bound students. So we're pretty excited about this. And of course, this is really dependent on COVID. We'll see what happens with COVID moving forward. So the map shows where the primary program starts. It starts in Juneau. All students and faculty fly to Juneau. And then students actually do the primary program. They do a 2-month traverse across the ice field. They hike up to the ice field and they stay at Camp 17 for a week or two. Then they traverse across to this ice field camp to Camp 10. Camp 10 is our biggest camp. I'll show you a picture next of Camp 10. And then from Camp 10, they can access most of the ice field by ski, snowmobile, and that's where a lot of the science gets done on the ice field. Camp 18 is another phenomenal location where a lot of science is done, and then Camp 26, same thing. So this is kind of the meat of the ice field where a lot of research is done. And then they traverse off the ice field, they get to Atlin, British Columbia, and they catch a boat to Atlin. They give community presentations in Atlin. It's probably one of the bigger things that happens in Atlin every year. The entire town shows up for it. Really exciting thing for Atlin. And then they actually work with Mendenhall Glacier Visitor Center to provide a presentation as well. And I should mention, Mendenhall has about a quarter of their display and their museum is dedicated to the Juneau Icefield research. They get about 600,000 visitors per year. So they're a great partner with us. This is on Tongass National Forest land. So we have a really good relationship with the Juneau community. It's been a fun in that regard over the past several years. So I mentioned we have an academic curriculum as well. You know, we have teaching faculty come in, and this curriculum is designed by about a dozen educators from around the world, and it's revised every year. We have an academic council that gets together and actually works on the curriculum, works on the pedagogy, and we disseminate this curriculum to our teaching faculty that come in and teach, and we work with them on designing curriculum that meshes with current science that's being done on the ice field, as well as the basics of Earth system science. So that said, we kind of use glaciology as the primary topic, with the concept that glaciers are affected by climate science, and they also impact oceanography, and there's a lot of relationships between glaciers and geology. So this is the general curriculum. I have 3 things highlighted here. I have science communication skills, sustainability, and becoming a leader within your community. Those 3 things have been, I think, probably gotten more discussion in the last few years than any topic that we talk about. And I think it's student driven. You know, I went to Nate Wood's and Tony's presentation yesterday. Hopefully a lot of you saw it, but I think there was a comment in the presentation about learning from your students. And I got to say, we learn more from our students probably than they learn from us in some ways. And I think the reality is most students today, they don't want to be an expert in a topic. They want to make a difference. They want to basically make a positive impact in their communities and their society. And you all know this. I'm preaching to the choir, right? So that's how we're designing this program nowadays. You know, a lot of what we teach in the ice field is focused on, okay, what can you do with this information when you go back to your community? How can you make a positive impact in your community? And that's what we're chasing. That's kind of the dream moving forward. And to chase that dream, it's all about science communication. And there's got to be some sustainability concepts in there as well, right? So it's really these 3 topics that kind of tie everything together. And that's almost been our focus in the past few years for the program. So I said I was going to show a picture of what our camps look like. This is one of our camps on the ice field. This is Camp 10. This location has capacity for about 75 people to be there at one time. We have a library, a lecture hall, lodging, you know, cook shack, and you know, some other kind of facilities, bathrooms. It's rustic, but it's basically will keep you out of the wet and weather. And for reference, where it says Taku Glacier in the upper picture, that ice is about 1,500 meters deep. That's effectively the thickest temperate glacier on the planet. So what a spectacular place to have a study site, you know, to have a camp sitting there. This is a one-of-a-kind location. It really is. There's no place else on the planet that has something like this.
Hey, Seth, can I jump in real quick?
Yeah, sure.
So as a 17-year-old, that's how old I was when I went on this thing. One of the things that Seth doesn't talk about here, but you learn really quickly in a camp environment, is how to get along with your campmates and how to cook food together, how to be part of the team that cleans up, how to do all of the aspects of what it's like to live in an expeditionary environment. There's a phrase that the former director used to used to say to us that was, don't be that dry corner guy or the dry corner tent person. And it was, you know, like one of those inspirational beginning speeches, but it ended up being true the whole time. You know, there's a wind flapping tent fly that's blowing around, or there's a problem out there. And what the culture that was part of this program really brought to me was that if there's something going on that is affecting your community, and that community is this camp, you are so much interdependent on everybody with how you talk, how you listen, how you respond when opportunities come up for making a difference. I would say that was as big of an influence on my life as the scientists who took me under their wing and said, let's climb down this glacier and go sample, you know, snow that fell in the 1943, you know, atomic bomb testing, because we can catch the strontium layers or whatever that were in the air particles that were there. I mean, all of it was awesome, but the big learning that I took away really came from, if you're in a community, it's not about you, it's about, can we make the program successful and move forward? So that was my little moment to add that. Thank you.
That's a fantastic point. And, you know, I think, you know, another important part of this is we have people coming to the ice field from all walks of life. And I'll talk a little bit about that in the next few slides. And I'm going to flip through. This is actually a perfect segue, Adam. You know, I'm just going to flip through some examples of, you know, this is a traverse, you know, what a traditional traverse looks like, you know, walking up onto the ice field. This is Tori was a prior student from Indiana, you know, low income student. She's now working on her master's degree at Tulane University. Colby is working on his master's degree at, Kansas. The photo on this photo shows Liz is from California. Annika, the person in the center, is from Juneau, Alaska. And James is working on his PhD right now in North Carolina. He's from North Carolina. You know, these experiences, you know, you build these relationships with people closer than, you know, your family in a way. You know, a lot of people really say that if you walk away from an experience like this, they're taking away from technology. They're not emailing people. They're not, you know, there's no internet, there's no phone. You basically learn more about these people in 2 months of time than just about anyone else you know. And it really does create this tight bond. It's hard. You can't say it's not hard. It is a hard experience to do the full traverse. That said, I'll reiterate what I said earlier, is like, you know, trying to scale it to make it hard but still manageable depending on where the student's coming from is an important goal that we have. So, you know, the upper bound programs that we're pitching are 2-week programs instead of 8-week programs across the entire ice field. It's scaling it down to making it a manageable bite to give students an introduction to this concept. You know, just some more pictures of what the scenery looks like, what we're doing. You know, it really is an immaculate area. This is a classic morning example where everyone is just like sitting outside, dumbfounded by the scenery, and just chatting about science and home and what it's like to be there. It really is one of a kind experience. What a place to lecture. You know, our faculty, probably they enjoy it almost as much as our students do, because this is the example. You know, this is Billy from Appalachian State is teaching a short lecture on ice dynamics and how ice stretches and flows with an ice fall right behind him.
I have a question, Seth.
Yeah, sure,
So
absolutely.
some people are in shorts and some people are in short sleeves,
Yeah.
but you see ice in the background. That's not like matching up to me. Can you tell me a little bit about the weather and the climate up there?
Sure, it really varies. You know, you have, I'm a hot-blooded person. I am 90% of the time in shorts and a t-shirt with a rain jacket when it's raining, but that's me. Other people, they really need to learn how, basically part of the program is actually learning to figure out what works for you in this environment. Everyone has a different need, and that's even part of our training. So for example, the upper bound programs that we're going to start running next year, the first week is actually dedicated in Juneau, and it's specifically focused on just learning to live in Southeast Alaska, learning how to layer clothes, what clothes work, what doesn't work so well. You know, we have people that have been doing this for decades, so we have a good handle on that. And it's basically one-on-one mentoring of that experience. So it really depends. Actually, you know, I love, so James, James and I are really close. We talk a fair amount, and And I talk like I don't think it's in this slideshow, but there's a funny picture of, James is from the Southeast, right? He's from North Carolina. And there's a picture I love where Annika is from Alaska, and she's like in shorts and a t-shirt, and James has like a full face guard and hat on, because it's just a different environment, right? But by the end of the summer, James is in shorts and a t-shirt because he kind of acclimatizes to the environment in a way, right? But it was just kind of helping James get comfortable with it. And, so he's actually one of the ones that'll probably be involved in the upper bound. He's pretty psyched about getting involved. So I have some funding for him to come back next year to actually start working with some of our students. So we're doing, yeah, go ahead.
The temperature there can be upwards of like, if that picture you saw with people sitting in shorts on a rock there, it could be 70 degrees out right there, but it's still ice underneath you. And that's one of the things that they teach you there really quick. Just because you're on a glacier doesn't mean you don't need sunscreen, doesn't mean you don't need to be, paying attention to things. I will admit to, within the 1993 JIRP community, we thought it was fun, and back then they allowed us to go swimming in some of the crevasse lakes to kind of prove our awesomeness or whatever. But 2 minutes in a crevasse lake, then you jump out and it's 60, 70 degrees out, and you can dry off in the sun and then go back to the business. So that was a moment you never forget.
I've had more days on the ice field where I was probably hot and sweating. You have a lot of wet days as well, but there are certainly days where you get really, really hot because the sun can be pretty intense there. This is Paola. Paola is working now on her master's. She's from South America. Phenomenal student. She's did an internship recently with a group at Columbia University. Let's see, Scott is now working on his PhD. This is the one in the front. Scott's working on his PhD in geology. I can't tell who the other three are in this picture right now. Digging snow pits from a science perspective. We've had a lot of ice core research being done up there recently. So this is a whole group of folks that are, students that basically were supporting an ice core research team, looking at kind of the structure of these glacier systems. Doing meteorological studies, so setting out instrumentation and actually linking meteorological observations to snowmelts over time, and also looking at water moving through systems. Doing radar, this is my expertise, so towing radar systems, measuring how thick the glaciers are, which has never been done, amazingly. Like this ice field, it's had some work done over the years, but you would think it would have been mapped out for years, but there's very little thickness information around the world for glaciers, so we have to rely on models a lot, but the ice field is a great analog for that. And so those are kind of examples of what students are doing. And then I have 3 examples of funded research teams, and then I'll have a couple more questions for you all. So these 3 examples of funded research teams, I wanted to show some examples so you get a handle on the level of work that people are doing. So last year we had a team, one of the several teams that came up, a team came from the US ice drilling program. They're directly funded by National Science Foundation, $3 or $4 million a year to basically support ice core projects around the world. So they had a drill system that they wanted to test on an ice field for a specific application. So they came to the ice field and they had our students basically working with them for 3 or 4 of the weeks that they were on the ice field. They successfully drilled to almost 300 meters depth, which is virtually unheard of in a temperate glacier system. If you know anything about glaciology, that's pretty challenging to do. And in fact, they thought they could make it to 600 meters. They just ran out of cable to lower the ice core system into. You'll see students here working. These are the IDP folks. This is a huge hit. This is NSF funded. And the students get a chance to see polar engineering in action and actually participate in it. Now I show this example with the concept of working together on the next project. So next project, we had a team led by Dr. Christine Foreman from Montana State come to the ice field on a NASA funded project. And her goal is to look at the spectral signatures of life on ice surfaces. And the idea being that if we can characterize those signatures on Earth, then maybe we can use technologies to characterize signs of life on other planets across the universe, right? So she came with her team to the ice field, and we had students working with her as well. And the beauty of this setup is she was also able to use the ice core samples from 300 meters down that would have cost $1 million for someone to do on a regular NSF funded project for her research, right? And the reason I highlight this is what we do is we actually have all our science teams reach out and communicate with each other before they come to the ice field. So it's much like your workshop here for NAEOP. You're communicating with each other. You're telling each other what works, what doesn't work. You're trying to build collaborations. The same concept applies. The NASA team had a specific topic in mind. The NSF had a specific team topic in mind, but they figured out they could actually do far more with their mutual resources. So that's effectively what we did. And what we're doing is we're also teaching our students that's how science should be done. That's how education should be done. It's a collaborative effort. It's not a competition. And that's a really important concept that we try to get across to our students to try to build those long-term collaborations over future years. So I'll show one more up here just because I think this is one of the raddest projects. Next year, we have the potential to have a team come from the NASA Jet Propulsion Laboratory and Caltech to test a new system that's an autonomous system, doesn't have a cable, that would drill through the Juneau ice field and ultimately collect a water sample underneath the ice field. This system, their goal is to deploy this to Europa within 15 years' time. This is a new project. We're hoping to have funding for multiple graduate students working on this. And this is an example of another project coming up that all JIRP students, upper bound students, would have a chance to participate in, basically. So I just thought this was a really neat one to showcase the value of having that collaborative research opportunities and education right alongside each other. The one thing one last thing I'll mention from the education and research side of things, we always try to have our students pick off a piece of the research that's being done for their own projects. So as a result, all of our current JIRP students actually present at a professional conference after the Juneau Icefield Research Program. So this is an example of a professional poster with publication quality figures that our students put together as a result of the research on the ice field. And in fact, this paper is just about ready to submit to the Journal of Glaciology, which is one of the highest level journals you can submit to. So this is exciting because we have, let's see, 1, 2, 3, 4, 5, 6 students on this, 6 students on this poster that they designed together. It was, effort from our faculty kind of giving input and mentoring and then teaching them about the data and teaching about how to collect the data. They collected the data. And they're going to be lead authors on the paper. So, that's the level that we're chasing here. And there's nothing that says we can't do this with upper bound students. And we know a lot of the programs in Maine, for example, and I assume a lot of your programs, students bite off specific research projects for their summer projects. That's exactly what we have in mind as well. So I want to pose 2 more questions here. And we're probably getting down to the wire here, but I want to pose a couple more questions here. This is how JIRP currently operates. JIRP, I kind of think of it as central, and how JIRP operates. It has tons of resources coming in from multiple groups. It's a nonprofit operated by the Foundation for Glacier Environmental Research. So it has a board of directors. We have federal organizations basically supporting the program in one way or another, either be research being done in the ice field or federal funding directly supporting education initiatives. We have nonprofit support. So for example, American Alpine Club is jumping in to try to help us in some ways. And then we have faculty and staff and volunteers coming from different institutions. And then we have tons of students ranging from high school through graduate programs. And then we have tons of, we have funding and private funding and donations coming into the program. So what I'd like to leave you a few of these points is, how can we foster more of these links from TRIO education programs? This is what I'd love you all to share with your colleagues after this presentation. Are there other ways that we can leverage more research opportunities for student engagement? Those are the types of things that I'd like you all think about after this presentation. Go back, chat with people. Yeah, sure. I see a hand.
Sorry, I was just curious. Obviously, in the COVID world we're living in, travel isn't really an option, but is there any remote link hookup possibilities to get students to, while they can't be in the camp, they can experience some element of the camp?
So 2 points. Mendenhall Glacier Visitor Center has asked us if we could do a remote link at Camp 17, and we would like to do that. I think they have funding to help us with that. We would love to do it. Once you get Camp 17 is the closest camp to Juneau, and you have cell phone reception there. So that's an easy one. So we could certainly do outreach experiences from Camp 17, no problem. Once you get to the main part of the ice field, it's satellite connection. But we have colleagues at NASA that have talked to us about potentially integrating some communication strategies that might help us bolster outreach. So that's certainly something that's on the table. So if you want to chat about that offline, absolutely.
And then I'd love to add to that and say one of the things when Seth first approached me about bringing Upward Bound students there with as part of this coming summer's program, COVID, what should I say, COVID accepting or COVID, however it works out, but
Permitting.
That's the word I was looking for. Thank you, Robert.
Yeah.
We specifically spoke about putting like an online curriculum together for some of the materials that he's already been, doing, so that the students who are part of T3 Alliance can join into a virtual course that brings them to the point of, hey, I understand a little bit about what glaciers mean and about what earth science is, and here's some of the specific types of technology skills that I might be able to use when I go out there. The intention is that this course is open for anybody in the T3 Alliance group, and they can check in and watch it. But if you can't go on the trip, then there's still a ton of learning and data and all the stuff that Seth mentioned there. That's the desk work of going back, incorporating GIS, looking at any remote sensors that we can put up there that can be sending data down, from Camp 17. If it's not the kind of live stream sending data, then maybe it's, a scientist can go and, plug the data back into some kind of a repository that can upload, and we can look at that together. But the idea of how do we make sure that this kind of an organization can reach as many people as possible, and that's and inspire those leaders to be moving forward. And that's part of what I'm excited to have him here as a Cadillac example. We all know that JIRP, when you look at those slides and when you see this level of organization, it's been run for 50 years.
75.
That's amazing, 55 years. But we also have groups, in our own communities, Denali National Park, other ones where there are passionate groups that are excited to give students the same kind of expeditionary learning opportunities that we know have the biggest impact for the amount of time and money invested on student long-term learning. So yes, definitely that's kind of like the golden goal here is, let's figure out a way to involve more students, make it virtual if you have to make it virtual, but still provide a pathway or a pipeline to one of the members of a community, or 10 members or 5 members, to be able to actually go and experience this. And as I'm sure Seth is going to go into, bring that back to their community and then use what they've learned there about being a leader, about being a scientist, about communicating with a small group, to turn that into opportunities that they can make a difference in their own community.
Absolutely. And Adam's reference, if you go to our website, you can, we already have a data link where you can access our meteorological station data, for example. You can see some of the papers published there. That's one example. NSF, NASA, they all have data locations as well that I'm sure you all have had some familiarity to, but that's a huge part of what we would love to see more of. We in some of the proposals that we're working on now, I'm working on a GeoPass proposal that would actually develop a kind of virtual reality tour across the ice field with all the geophysical data sets, the science data sets we're collecting, and have it scaled where, depending on the level of education you're at, whether you're K-8 or high school level or college level, that's the level of curriculum, and you can kind of work your way up on those models. So we're working with UMaine, and we have other programs to kind of get involved in that as well. And I should mention, that's, this is the first proposal, the GeoPass proposal. It's not definitive who we have on the team. So those are the types of things that I'm absolutely looking for, people that are keen to get involved in things like that. I'm doing the brunt of the writing for things like this, but that's my job. So if you're interested, reach out to me in that regard as well. So jumping forward, basically, so you have we're offering, I'm going to back up, we're offering JIRP as a community resource. That's the gist of it, you know, and there's a lot of opportunities here, I think, for that. So jumping forward, taking that material out back to the classroom. This is an example. You know, I just show I could show you 100 examples, but I'm showing you one basically. This is a model that my colleague, Dr. Brad Markle, made. He's at University of Colorado, and he's one of the associate directors for the program. And this model is basically showing trajectories of storm tracks across the Gulf of Alaska. And what he's been doing is they've been collecting with students, collecting snow samples and measuring isotopic values of the snow samples. And he's able to actually back calculate where that snow evaporated from in the ocean, which is pretty amazing, you know, to pull something off like that. But how do you explain that in the classroom, right? So, you know, there's a lot to it. We can do simple analogs. So I love eating, right? So one of my examples is a simple example of making pancakes, right? So you got 4 types of fruit here on the left-hand side. The pancake batter, as I make my pancakes, each pancake has a different type of fruit. That fruit represents some difference in chemistry, right? That's all it is. And that's basically that difference in chemistry. We can calculate where the evaporation occurred based on the difference in chemistry, right? So, you know, we're trying to draw links to what we're doing in the field, to how students can understand that in the classroom. But, you know, having the visual cues really helps. So our hope is to kind of use more of our material from the ice field with things like this, and input from you all of, you know, what level students you're at. You know, how do we engage them in the specific topics that you're teaching? How do we use the information we have back in the field with simple lessons to kind of get those points across? You know, here's my pancake stack. Another thing, you know, we look at ice cores. We drill ice cores. So my simple example of making pancakes, ice cores are basically looking at old ice to new ice. So if I was to drill a core from my top pancake down to my bottom pancake, basically I made these pancakes step by step. So the bottom pancake is the oldest pancake. And then I made another pancake and put that on top. And then made another pancake and put that on top. The youngest pancakes on the top, the oldest pancakes on the bottom. That's the same thing as an ice core, basically. We drill down through the ice and we collect ice that's really old at the bottom, new at the top. So this is an example of an ice core site, not on the Juneau Ice Field, but a project I was involved in Denali National Park that Adam just mentioned. We drilled 2 ice cores. And you can see this picture on the bottom right-hand side. You can see these layers in the ice. Those layers in the ice represent different chemistry. Well, where do you drill an ice core? So this is a flubber model. Has anyone ever played with flubber? No? Okay. So basically, it's like goo, basically, that you can make, and it actually flows like glacier ice does. So this is a flubber model sitting at an ice divide, which is where you traditionally drill an ice core. An ice divide is basically where 2 glaciers separate. One flows one direction, one flows another direction. This is a flubber showing that. This is a sketch that a student from the Juneau Ice Field made to kind of explain that, right? So again, back to the science communication concept. And now I'm going to jump into a lot more science communication. I mentioned that was kind of a theme. This is another sketch from the same artist looking at the internal structure of a glacier relative to the features where we're seeing in radar data. I'm not going to dive into the radar data for lack of time, but you know, you can see with this structure, he has this T and R here in the, that's a radar setup. It's sending signals down through the ice, the snow, fern, and ice. You see the signals coming back. He's got a meteorological station designed there. He's got a little ice course set up. These are all things that you can explain to the students back in the class. I love this postcard that a student made about ice change in Alaska. Basically, she took the science observations that the ice has been losing 2 meters of elevation per year and turned it into a little postcard to send home. You know, again, just a simple science observation tool. Glaciers have what we call mass balance. So mass balance is just like a checkbook. You have mass coming in or money coming into an account, all right? That's snowfall. And you have mass loss. That's ablation or melting or calving of the glacier system. So this is a gift that a student made to kind of show that process. So the white is the snow on the top and the ice is the blue, and you can see that snow kind of melting away. And then another, I think I have 2 examples left. This one is an example of looking at long-term change in glacier systems. One of the ways we use to study long-term glacier change is we use cosmogenic dating. And the premise of this is UHE is a undergraduate student now at UC Berkeley. She basically shows this by having snow melting away from exposed bedrock. And when snow melts away from exposed bedrock, cosmic rays actually hit the bedrock, and the cosmic rays interact with quartz. And the quartz and the cosmic rays create beryllium-10. And we can actually, and that creation occurs at a constant rate. So we can actually tell how long the bedrock is exposed by figuring out how much beryllium-10 is actually in the bedrock, and you can create a timeline of deglaciation over time. And that's how we know glaciers have retreated. That's how we know rates of retreat. So these are the types of things that students are doing to kind of bring that back to the communities and explain the concepts. And this is the last one. I love this. This was one made a few years ago by another student, Abby Case, looking at vegetation succession after glacier retreat, and the actual kind of encompassing all of Earth sciences in a way, right? You have the glaciers, and you have soil development, and you have ecosystem science around it. I think this is just a really nice representation of that. And again, this kind of brings back to what can we do to bring real science from JIRP back to the classroom. This is something that we are actually studying on the ice field that can easily be done in your own backyard. And, that kind of hammers home the point that Adam made, that a lot of these observations can be made in your own backyard, and drawing relationships between Alaska and Maine and Florida and Colorado and North Carolina, any of these places. Really, there's a lot of these observations can be made. So with that, I'll get to the upper bounds. This is the short part, the future, and what we have planned coming up. So right now, our goal is to offer these new upper bound programs for students. Right now, we have folks from the state of Maine. All 5 institutions that have upper bound programs in Maine have signed on to this. They expect to provide 30 students or so. I've been working with Adam and their team to provide another 30 students or so, hopefully. We recently found out that colleagues in New York are interested in this, and they have 10 students right now already interested in the program. And we're working on developing more relationships and more opportunities. We can take about 35 students per 2-week program. We want to run multiple 2-week programs based out of Juneau for 1 week, and then a day hike or quick helicopter flight, either or, to our field camp that's close to Juneau. And students would spend a week there in our buildings and working on the glaciers and the sides of the glaciers with our science team, educators, and safety personnel. We're also working, I think I mentioned earlier, we're working on an NSF proposal. It's called Geopaths. So if you're interested in kind of learning more about that, shoot me a message. And again, I'll kind of leave it with the bringing STEM education back to the classroom as well. It's not just about the getting students there. I really want to make sure we get this material back to the classroom. And the last thing, this is almost like, this is something that's been developing. And as of today, pretty exciting. I just got news that we at Maine are going to submit a $2 to $3 million congressional pitch with colleagues from Washington, Alaska, a few other states, to try to turn the ice field into a polar earth and planetary science proving ground with educational support. So what that would mean is we would have all of our field staff, faculty, costs funded directly by Congress on an annual basis to support these initiatives. So basically the upper bound programs would just have to cover your student costs and your own personal costs to come to the ice field, but otherwise everything else would be covered. And so far I've had conversations with Senator Murkowski's staff, Maine congressional staffers and senators, as well as our representatives. We've talked with New Hampshire. We've wrote a white paper per NASA request with authors from 5 states, from Maine, New Hampshire, Montana, Washington, and Colorado. And you'll see we have, that's the blue on the map. The red sites are places where we have people interested in joining on to that effort. So we're starting to get nationwide interest in this concept moving forward. So we're pretty psyched about that. So I'm going to end it on this slide. This is a couple slides that some students, some colleagues at Hanson Dodge, their marketing firm, they're volunteering pro bono, and I think they capture the concept really well. This is a program that does transform students. It really, they come out of this. The most common term that we get from students and feedback is inspiration. Just about every student that comes out of this program is inspired. They change tremendously. I don't know what Adam was before, but I can imagine, you know, who knows, but he's pretty stoked. So, you know, it really is a transformation. So I love this little cocoon example, and it really is, you know, a classroom like no other. And I think you all recognize the value of these types of things. And I'm going to, you know, go back to the point, it costs money to do these things, but I'm more the guy that I don't care it costs money. I just want to figure out how to make it happen for more students. So with that, I'll shift to the last two slides. This is just a summary slide, doesn't really matter, but the last one is, these are the questions that I pitched and some more questions below for potential thought processes about how we might evolve this into the future. I will mention that I am, so I fell into this role directing JIRP a few years ago. Maine has been really supportive of this process, but I'm all about trying to build a multi-institution consortium nationwide for something like this, because I think this is the type of thing that needs to be in our communities. It needs to be community run. I don't want to be the person that's just running this big grand beast, because I feel like that causes bottlenecks. So, you know, those are the types of things I'm looking for in the future, and would love feedback, thought process, and anyone who wants to get involved in the future, reach out to me. With that.
Awesome. Awesome. Thank you so much, Seth. I think there's just so much to say here, and there's so much to bring back to our institutions. I did screen record this so that in the event that people want to see it faster than it takes the NAEOP guys to get it live, then I'll have this for later for you to share as it goes along. The question I came up with, as you showed that one slide of, you've got a nationwide consortium of being an education place. Do you need help reaching out to congressional folks? That's one thing. And then the other part is, well, I forgot it right there, but I'm assuming that the question is, yes, if you've got Alaska senator and Maine senator and other senators know about this, is there ways that we can be part of that?
You know, honestly, you know, I had a conversation today with our state of Maine's, University of Maine's Office of the President here, and this concept of this, you know, $2 to $3 million pitch that would ramp up to, say, about $5 million annual funding to support things like this. I think the more support we could have at the congressional level from multiple states would be huge. And again, it just goes to the consortium concept. You know, I think you don't get these things off the ground. I'm a big thinker, and a lot of the people at JIRP are big thinkers. We're proactive. I think you all are in the same boat. You know, you have to kind of get these things running, and it doesn't happen by one or two people. It really needs to get buy-in by other people. And, you know, I don't have the connections at all the different states. So anything that people want to, if people want to jump in and try to chase more connections and try to pitch these types of programs, by all means, you know, let me know. And I'm happy to provide wording or phrases of like what we've actually been doing to kind of make this pitch. You know, as far as I'm concerned, it's us that has the capacity to do this. You know, the team that we have around right now.
Awesome. Well, what I can offer as a T3 Alliance person, I can offer to facilitate an avenue through which people in T3 Alliance can have access to sending a student on this somehow. I'm not sure how, but I know that one of the reasons Seth is staying around for our 2-day training after this, the post-conference, and his grad students are working on building the curriculum backbone so that we can start sharing some of what he's doing directly with students. Because we know it's a big ask to get a student to say, oh my gosh, go to Alaska, be on that kind of a thing. But it's a little lower ask to say, hey, would you like to be involved in this course on glaciers and climate change? And if there's some way in which in that course, a student can make some measurements in their own community, you know, sea level, temperature changes, noting things about, you know, the biomes moving around things. We all have a little ability to contribute to a global data set. And if that becomes the inroad for making organizations like JIRP be more accessible to upward bound programs and student support services. Seth, I did have one person in the chat over there who asked, are there opportunities for undergrads to be involved with things you do in JIRP?
Absolutely. So the primary JIRP program is actually undergrad. So the regular 2-month program is an undergrad program. As I said, it costs money to do that, but if basically we deliver scholarships based on a as needed basis. So if you have undergrad students interested, send them to the website, send them to me directly. I mean, we're a small enough program that I answer my emails, so
Cool.
have them shoot me an email if you have students keen on this. And we've had students that have applied a couple years in a row. We didn't have funding from the first year, we got them in the second year, type of thing. And it just depends on the funding each year. You all know this beast. We try to reach as many students as we can. So we also, one thing I didn't mention is we also have students with a range of backgrounds. They don't have to be math, science, physics heavy. We have students that come up that are interested in art, science communication, science policy, sustainability. So that's an important topic. It really is a mix and mash. We want people with that range because that's the real world too, right? And we also have students that we would say come from liberal families, conservative families, that cover the whole gamut. And it's about having that dialogue and that communication, I think, is really important. I come from a very conservative household, small town Maine, and I feel like that's an important thing that we all have to work together. So I think that's a big piece of the equation as well. Yeah.
Just gonna say that what jumped out at me was relevant, and what you're doing is relevant and real, and that's something I think really is attractive to students. And I like that you mentioned about science communication, because that's just what jumped into my head. It's like, how can we get this conversation with students doing the real work and then communicating that out to students who can't necessarily show up on the ice field, but being able to make that cross communication, that to me would be a real win-win. Because I'm just hearing about all this and I'm just like Adam Space does a much better job of illuminating what I'm thinking and feeling about the project.
Well, I think you illuminated that very clearly. One thing, another thing I forgot to mention, Nate and Tony's talk yesterday, we do a lot of near peer mentoring too, right? We have high school students that are mentored by undergrads. We have undergrads that are mentored by graduate students. We have graduate students that are mentored by postdocs and all the way down the line, right? So there is this kind of near peer mentoring opportunity too. And I think your example there, Robert, of bringing it back to the classroom is a peer mentoring opportunity. Absolutely.
We had a question in the chat about how do you sign up for the program for next summer, and I'm also interested in that from a non-T3 perspective and a T3 perspective.
Sure. So first, I guess you mean students sign up for the program or faculty?
Students, I would assume.
Cool.
But
Yeah. So basically, the faculty applications will actually open up online on our website probably next week. So if you go to the website, it's listed in the upper left-hand side of this slide that's shared right now. There will be an application page on the website that students will have to fill out. There's additional applications for faculty interested in involvement. One thing I would also recommend for folks that are interested in involving themselves in the program or trying to build collaborations, there's an opportunity for you to sign up as a faculty, and you could basically just enter your information and make a note that says interested in trying to develop collaborations between JIRP and TRIO programs. That helps me because it allows me to kind of put you on a mailing list to kind of not bombard people that don't necessarily want to be involved in it, to kind of start this process. So I would actually encourage you all to do that as well if you do have an interest in the future.
And I'll add in there just because that question I saw that we're not T3 and we are T3. When Seth reached out to us as an Upward Bound program, he wasn't reaching out to UAF as a T3 program. I responded to him that, boy, all my students do T3, and I know a bunch of other places that do T3. And if we could have like a little bit of a curriculum that could be accessed before the trip, then that might be awesome. So I want to point out that T3 is something that isn't you know, you don't have to be part of the original National Science Foundation grant to be part of it. Jasmine's an example of they just joined in, and if you want to talk more about, you know, becoming part, we think we try to make things as cheap as possible to have a low barrier entryway and access a bunch of students. But if there is an opportunity to bring students to the ice field next summer, just say, and students have had a chance to get into a, you know, like a course and a Discord channel where they could talk about the excitement of what they're going to be learning about before they get there, then I would venture to say that's going to be a greater experience for that group of students. They'll have known each other before they made it onto the ice field. It's not the only way, and Seth started this grant, and he's been looking into ways of making it happen where just, you know, here's a main group that said, I want to go, but I'm too busy right now to deal with the details. Seth, you figure out the details and we'll sign students up. We'll have 20 students ready to go. And they haven't been able to, you know, join into T3. But I'd say we're at that beginning phase where partnerships and interested organizations are going to make for a stronger and stronger application. When Seth has a list of 20 Upward Bound programs and 20 SSS programs that are around the country that are craving an opportunity to have students be a part of this kind of experience, and he goes to the Congress or he goes to whoever and says, hey, can you fund this? Then that's the balance. The other thing that Seth is really good about doing is knowing that you are at a research institution or you're at a university that may have some ties into somebody doing glaciology, somebody doing climate science, somebody doing something. And not only talking to me or, you know, to me, an Upward Bound program director, but also talking to, you know, who is at the University of Alaska who does stuff on climate science. And there's a lot, you know, so both of these avenues make for great partnerships. When we can say that California has brought us this many people, or Washington has brought, you know, a consortium of 6, you know, Upward Bound programs that also are being, you know, overlooked by these 5 former JIRPers, or JIRPer is a term we use for somebody who's been to the Juneau Icefield Research Program, and that mentoring is a pretty powerful opportunity.
Yeah, that's a good point, Adam. And I should mention, I didn't dive into this, but the way the current program works, which I can envision these Upward Bound programs working as well. We basically have faculty apply that want to participate in the program, and basically many of the faculty pitch specific research topics or ideas that they would like to have students participate in. And what we try to do is we try to have a core set of, say, like 6 to 10 research projects that students will work on together collectively, and that research topic ends up being their take-home presentation at American Geophysical Union conference or at their home institution. So I can envision something similar where if you all have a specific idea, like Adam has a specific idea looking at, glacier seismicity using, some raspberry shakes, for example, that can be one of the projects, looking at, how often glaciers kind of create seismic movement, and what's, trying to relate that to the actual physical observations we're making on the ice field, right? So those are the types of things that we're looking for. So it's definitely a brainstorming session. And so what happens is when you apply to the ice field, the more information you can provide me about your program and what your students traditionally do through the summer, through the rest of the year. Do they usually do research topics? If not, do you want them to do some research or like be involved in something like that? The easier it is for us to kind of come up with a cohesive collaboration that really helps students get more bang for their buck, I guess. And again, not their buck, but the more bang for the actual program, I guess. So any ideas you have, we're all ears, very open to pitching. This is like, okay, this is going to be one of the topics that we pursue for the year.
Awesome.
I think I'm gonna have to email you, Seth, because I have I come from a very rural place here. There is no, there's a very basic high school science program. We've got a new science teacher this year. So there's what I want for my students is the trip to Alaska, the glacier, the experience. It's really hard to get them to engage with anything that isn't hands-on.
Yep.
And so I just want to know, like, oddly enough, COVID has boosted our budget hugely because the entire spring we didn't run anything and we have our carryover. So we're trying to spend down some money. And so we're getting pretty ambitious about what we can do
Yep.
in next summer, because we're going to have a lot of carryover. So this might be an opportunity to send a bunch of kids to Alaska and do this. And so I just want an in for that. And what can they bring back? You know, big eyes, you know, like, oh my goodness, you have no idea what's outside this little town of Tenasket.
Yep.
So that's what we're looking for. I'm hoping we can find a way there.
Yeah, please do shoot me a message, Alex. Love to hear from you. Yeah, I mean,
Cool.
like I said, it's a resource that I want you all to be able to use. So
Fantastic. Thank you.
Yeah.
I'm inspired.
Cool.
awesome.
Well,
I want to go.
Goal. I want to go back too. So
you totally
Yeah.
need to go. It is
I'll find
just
some
the
students
coolest.
so that I can go.
Right.
you can. Oh, one thing I forgot to mention. So NSF did sign on next year to try to, we're doing this trial run, but they said they would give about $50,000 to run a workshop conference. But the people that were kind of covering their costs will be helping to administer the actual program itself. But I'm going to open it up to people that might want to come to Alaska, to Juneau, to kind of get a taste out of it, you know, to stay there for 3 or 4 days, kind of mesh with people, chat with people, brainstorm ideas. So that announcement will be coming out at some point. I'm guessing I'll probably tag Adam to help
Yep.
disseminate that information.
And we will help you, you know, learn how we have to craft the wording so that it fits within what we're allowed to spend as a trio program. Because as you
Yep.
know, like sending a student is no problem, but sending faculty or staff, you know, there's all those hoops that we get to jump through. So having some creative templates that we can bring and make
Yep.
sure that we use. But
Exactly, that'll be huge. So
folks,
yeah, so
thank-
keep an eye out for that as well.
Thank you so much for attending here today. This has been just a pleasure, and just like in Seth's beginning picture and end picture, to me, it's just like one of the highlights of my life career to get to come back and talk to you guys about, you know, Juneau Icefield Research Program at this point in my life. So I hope to do everything I can to, you know, be a spokesperson and help Seth do the good work and continue the work that he's been doing.